So in this video, we would like to derive the formula to convert the temperature as measured in degrees Celsius to that in degrees Fahrenheit and the opposite. We know that the relationship is linear, and we know that 0 degrees Celsius corresponds to 32 degrees Fahrenheit, and that 100 degrees Celsius corresponds to 212 degrees Fahrenheit. So since the relationship is linear, we can use the equation of a straight line, y equals mx plus b. And in this case, we'll start with our x. Our known is the temperature in degrees Celsius. Our y will be our temperature in degrees Fahrenheit. M is the slope of the line, and b is the y-intercept. So let Tf be our temperature in Fahrenheit, and Tc is our temperature in Celsius. So the equation of our straight line is Tf equals m times Tc plus b. So we'll call that equation number 1. M and b are our two unknowns. So one piece of information that we have is that when Tc equals 0, we know that the corresponding temperature in Fahrenheit is equal to 32. So that is, we'll call that 2. And then the second piece of information, we know that when the temperature is 100 degrees Celsius, which is the boiling temperature of water, the corresponding, so this is Celsius, the corresponding temperature in Fahrenheit is equal to 212, and we'll call that number 3. So if we substitute 2 in our first equation, so Tf is equal to 32, so that is the left-hand side. M is our unknown slope. Temperature in Celsius is 0, and then b is our unknown intercept. So m times 0 is equal to 0. So immediately from this equation, we find that b equals to 32. So this is one of the unknowns. We call that number 4. And if we plug 4 in 1, let's update our equation. So our equation now is Tf equals m Tc plus 32. So that's equation number 5. So we found out b. Now we need to find out what m is. So to do that, we'll take our second piece of information and we will plug it into equation number 5. So we know that when the temperature was 100 degrees Celsius, the corresponding temperature in Fahrenheit is 212. So 212, that's the left-hand side, equals m times 100 plus 32. So let's move m to the other side. So 100 times m equals 212 minus 32. So 100 times m equals 180. So m equals 180 divided by 100. So 1 0 will cancel the other. And then if you divide numerator and denominator by 2, so that will give us 9 over 5. So m equals 9 over 5. And that was the second piece of information. We'll call this number 6. So if we plug 6 and 5, that will give us our final equation, which is Tf equals 9 over 5 times Tc plus 32. And let's call that equation number 7. So equation number 7 gives us the temperature in Fahrenheit as a function of temperature in Celsius. And we said we want to derive the opposite equation. So using 7, we're just going to shuffle things around. So we can move the 32 to the other side. So Tf minus 32 equals 9 over 5 times Tc. And if we multiply the entire equation by 5 divided by 9, and I'm going to move Tc to the left-hand side, that will give us Tc equals 5 over 9 times Tf minus 32. So this is equation number 8. And this gives us the other transformation. If we have the degrees Fahrenheit and we want to figure out what the temperatures in Celsius is, so this gives us Tc as a function of Tf. So one interesting question is there a temperature in Fahrenheit that maps to the exact same temperature in Celsius? So to do that, let's use equation number 7. So we want to figure out if there's a temperature. If I plug in a temperature in Celsius, do I get the same temperature in Fahrenheit or not? So let's call that temperature X. So let's say TF equals TC equals X. And let's plug that into equation number 7. So X equals 9/5 times X plus 32. So that's 9/5 X. So I'm moving that to the left-hand side, minus X equals minus 32. So essentially I moved 32 to the other side and moved X next to the 9/5. So we can take X as a common factor. So X times 9/5 minus 1 equals minus 32. So 9/5 minus 1 is essentially 5/5. So that gives us X times 4/5 equals to minus 32. And if you multiply the entire equation by 5/4, so that gives us X equals minus 32 times 5/4. 32 divided by 4 is 8. 8 times 5 is 40. So that gives us X equals minus 40. So actually, minus 40 degrees Celsius is actually the same temperature in Fahrenheit, minus degree Fahrenheit. This is the only temperature on the Fahrenheit and Celsius scale that maps to the same value on the other scale.